for today, for day 146, we're going to learn about arithmetic sequences or patterns. And when we think about these patterns, I want you to think of them in regards as them being linear, okay? So they're always going to have a linear progression, okay? Which means they're going to have a pattern that is straight across the graph. Okay, I'm going to ask you guys again, please quiet down, okay? I've started, so we get to talk later. Is that good? Good. So, can we put something in our notes right here? Take arithmetic and let's put linear by there, just to remind you. So we're going to talk about arithmetic and then geometric. So there's two kinds, but there's all sorts of patterns you can figure out. But there's two main ones I want you to think about. And in mathematics and in real life, you'll see patterns, so it's important to understand how the patterns work so you can predict what happens in the future, right? Okay, so let me go up ahead. Here are the steps that we're going to do today. We're going to identify A sub 1, which is the first term, and D, which is the difference, and then we're going to put them into these explicit formula, which is right here. And then we're going to simplify that, and then finding the nth term, replace the number into the n of your new formula. So take a moment to write these down if you haven't yet. Here we go. So on number 1, we have to determine the sequence if it's arithmetic, and then figure out the common difference if it is arithmetic. So just looking at number 1, what pattern do you notice on number 1 here? I'm going to hide number 2. Turn your neighbors, what do you notice is happening from each number to the next? Okay. What are you noticing? Okay, what's happening?
It goes up by 100.
Yep. Good, going up by 100, right? So if it's going up by 100, we're noticing like this first number from -4 to 96, I'm adding 100, right? From 96 to 196, we're adding 100, right? Okay. Bring me your phone. Braden, thank you. And then from 196 to 296, bring me 100. All right, so it's our common difference. So if you know this, what do you predict the next three numbers to be? What's the next three numbers?
396.
396, then what?
496.
And then?
596.
Good, okay, so this one's pretty simple, right? We got 496, 396, right? And I could predict, what if I just wanted the sixth term? You could say it's 496, right? So this is an arithmetic sequence because it goes up by the same difference every time, going up by 100, right? And you can make a prediction because there's this pattern. We know that the sixth term is 496. Okay, number 2, turn your neighbors and tell them, what's the pattern? Is it arithmetic or not? And predict the next three numbers, okay? Go. So what's the pattern? Yeah, Seth. Okay, so you're noticing it says +3 and then +5 and then +7. Do you all agree with Seth? Yep, so is this arithmetic? Is it going up by the same amount every time? No, it's not. It's going up by 2 more every time, right? Is there a pattern? Yes, but is it arithmetic? No, it's not arithmetic. So we could still predict the next few numbers. What are the next few numbers?
28.
Uh-huh.
39.
Uh-huh.
52. I don't know.
Yeah, that's right. Okay, so this is not an arithmetic sequence. I'm going to put not arithmetic because it doesn't go up by the same amount, okay? So that's what an arithmetic sequence is, okay? So we want to know this because you could see the patterns under here. So now I'm going to show you how this looks on Desmos, okay? So let's pull up Desmos. I'm going to pause the video here to go to Desmos because I can't record it. So all you got to talk to your neighbors about is it arithmetic or not? If so, what is the common difference, okay? Go. What do y'all think? Is it arithmetic? Yep, 3 is. Good. What's the common difference on 3 then? Good, negative 20, that's right. So it is arithmetic, and your common difference is negative 20. What about number 4?
Yes.
No.
Is there a pattern?
Yeah, they're just adding 3s.
They're just adding a 3, so what's the next number going to be?
It's going to be 1,793,333.
Good, 1,793,333. That's correct, okay? So, but is it arithmetic?
No.
No, it's not. Okay, so, you know, there's patterns. We could predict it, but it doesn't mean that it's arithmetic. It's not linear, okay? Awesome. Let's keep going here. So now that we've talked about the basic and got some concepts going, okay, then we're going to talk about the procedural stuff in math. This is the boring math stuff, okay? But you still need to know how to do this, okay? So numbers 1 and 2, I'm going to show you how to, like, if there's a problem on a test, this is how you do it, okay? So we got 3, negative 4, negative 11, negative 18. Okay, I'm going to give you the easy part here, or ask you to help me out. Is this arithmetic or not on number 1?
No.
What's the common difference?
Negative 7.
Isn't it negative 7? 3 minus 7 is negative 4. Negative 4 minus 7 is negative 11. Negative 11 minus 7 is negative 18. Is it arithmetic?
Yes.
Good, so the common difference here is negative 7, right? We have 4 numbers. We have the first, second, third, and fourth, so I want to see it that way. And the common difference is negative 7. So what I'm going to do is I'm going to take my... Oh, and the first number is 3. So these are the 2 pieces of information you need to make your equation. So you see on step 2 here, we have an explicit formula equation. So we can get any number in this sequence by using this equation. So we're going to write the original equation down, and then we're going to plug in some of these other numbers into and substitute them into the place, okay? So our a sub 1, which is our first number in the sequence, is 3. So I replaced a sub 1 with 3. And then our common difference we said is negative 7. So this is your explicit formula, okay? Meaning we can find any number in this whole series of numbers, infinite, by the way, this is infinite. These 3 dots means it goes on forever, right? So it's asking, what's the 27th number? So how would you figure that out? You just rewrite this. You say a sub 27, or the 27th number is 3 plus. And remember how I replaced n with 27. We're going to replace n here with 27. So it's going to be 27 minus 1, all times negative 7. And then I'm going to simplify this. I get 27 minus 1 is 26 times negative 7. Okay? 26 times 97, really quick. What is it, everyone? It's kind of hard, right? So get your calculators out. Let's go. What's 26 times negative 7?
Oh, that's going to be...
Negative
3.
Negative 172.
Negative 182.
Negative 182.
Negative 182, not 172. Close. That was good, though. That's okay.
Sorry, Ash.
Oh, oops.
Okay? So we got 3. Oh, there's your answer. Okay, negative 182. And then what's 3 plus negative 182? Negative 179. Okay, so that means that the 27th number, if I were to write all these out and get to the 27th number, it would be negative 179. Okay? So that's how you do that. Now, I just showed you 2 ways, right? I just showed you on Desmos how to do it, and I just showed you this calculating way. Which one do you prefer? Desmos or calculating? Tell your neighbors really quick. Which one would you prefer? Desmos or this calculating way? This formula. Okay, raise your hand if you prefer Desmos. Raise your hand if you prefer this way. Just write it out and calculate it. Yeah. Is there a right or wrong way? No. But you should know how to do both. That way you're flexible, right? Okay. Number 2. Number 2, almost done. Number 2 here. Is this an arithmetic sequence? If so, what's the common difference?
Negative 4.
Good. Okay, so we have difference of negative 4, and we're going to try to figure out what's a sub 28. So then I would go and figure out my explicit formula, plugging in the numbers into it. So we're going to replace a sub 1 with 40 because that's the first term, and then negative 4. But I want to know what's a sub 28. What's the 28th term? If I were to write 28 numbers in the sequence out, or series out, what would it look like? Or what would the number be, okay? So with your group now, number 2, I would like you to work this out. Tell me, what's the 28th number? Go. Negative 112?
Yeah.
68.
Negative 68. Negative 68, right? What's 28 minus 1? 27. 27 times negative 4? negative 108 plus, and then we have 40 plus negative 108. Okay?
That's
So, the goal of this is really, so you see there's a pattern. It goes in a linear format. You get, and I want you to think conceptually, in your life, I want you to think that if you can get into patterns, listen. In your life, you can get into a systemic pattern, sometimes for your own benefit, and you can make predictions about the future. For example, if you have a job, okay, everyone know what a salary is?
Annual.
What's a salary?
So like how much you get like
Every year.
over an accumulated time.
Good, and let's say you get a salary, do they pay you only once a year?
No.
No, they pay you like once a month, right?
Pay you once
So
a year.
let's just say they pay you like $10,000 a month,
So I want that job.
okay? And let's say you're trying to save up money for whatever, like one of Jonathan's expensive dogs, okay? Right? Let's say he has like this really expensive dog that's $25,000. How many months do you have to wait till you get that?
3.
3, right? That's if you save all of it, right? Does that make sense? Is life perfect though as $10,000?
No, you have taxes.
You have taxes, you have all this stuff, right? But there's still consistency, there's still patterns, and I want you to think that there's patterns, okay? All right, that's it. So, I would like you to now talk about these. Sorry, this last question looks funny. 4 questions. I'm going to call on you. I'll give you 2 minutes to talk about these 4 questions. Okay, ready, set, and go.